Welcome, and thank you for joining us for EMBCA's Innovation Fusion Centers from the United States to the Hellenic Republic webinar panel discussion, all in association with the Greater Harlem Chamber of Commerce. My name is Lou Katsos, EMBCA's president, and we'll be co-moderating this panel discussion with Technologist and EMBCA director, Eric Hill. Our distinguished panel today includes Dr. Vincent Boudreau, president of the City College of New York, CCNY, Innovator and military veteran, Cameron Hunt, Ideation, business development and collaboration catalyst, Eugene Francis, technology executive business ecosystem strategist, Tom Katsoulias, and information technology project manager entrepreneur, Stavros Messinis. As we move forward in the 21st century of rapid technological advancements, both the US and the Hellenic Republic have to continue to look at and expand innovation brought on by the collaborative technological fusion of civilian, government, military, and academia as an underpinning of civil and national security strategies. Supporting this are various funded government and commercial programs to accelerate dual-use technologies, appropriate application in the defense industrial base, as well as the civilian commercial economic base of their respective nations. And yet none of this is possible without a sustained youth STEM pipeline that has to be taken into serious consideration. Today, we will be discussing unique technology and program innovations spanning from the United States to the Hellenic Republic with seasoned professionals from both nations to discuss incubators, accelerators, research and development centers, open innovation centers, Imagineering technological advancements, and business and STEM education strategies related to technologies and entrepreneurial activation. We hope this conversation contributes to a wave of expanded innovation and research in that regard, as well as strategies for companies, educational institutions, and political startups through strategic partnerships and innovative marketing and branding. A little bit about our co-moderator today, Eric Hill. Eric is a technologist in the third decade of his exceptional career. He holds a bachelor's degree in computer engineering from the University of New Hampshire. Early on, he was involved in the rapid expansion of network infrastructure and distributed management systems that culminated in the dot-com boom and later explored and researched data warehousing and analytics. In the last decade, Eric has become immersed in advanced automation efforts over critical infrastructure, as well as in various areas of cyber and cybersecurity interfacing with a number of tech industry organizations and has extensive experience in the defense sector. He specializes in dual-use technologies, providing cyber capabilities to the defense and intelligence community, and has presented at various defense-oriented venues in the United States and abroad. His significant and acknowledged volunteer efforts has been youth-centered over the years, and also with a laser focus on STEM pipeline development, mentorship, and empowerment. He is a volunteer director of EMBCA. Welcome, Eric, and thank you for being with us today. Our first panelist guest is Dr. Vincent Boudreau. He was appointed president of City College of New York by the Board of Trustees of the City University of New York in 2017. Prior to that, he served as the founding dean of the Colin Powell School of Civic and Global Leadership at CCNY from 2013 to 2016. A specialist in the politics of social movements, particularly Southeast Asia, he also conducts research about government transitions to democracy, collective violence, and the relationship between civil society, social movements, and democratization processes in Indonesia and the Philippines. Vince is also a very active member in the Harlem community, where CCNY is located, and is a board member also of the Greater Harlem Chamber of Commerce. Welcome, Vince, and thank you for being with us today.
Oh, thank you, Lou. It's a real pleasure to be here. You know, as your introduction highlights, I come to this conversation, I come to the presidency with a background in the social sciences. And so here I am 6 years ago looking at CCNY, which is the place in the City University of New York where they've made the biggest investment in technology. So we have the Advanced Science Research Center is located on our campus. We have another facility called the Center for Innovation and Discovery, billions of dollars worth of scientific equipment in those two buildings. We have the only public engineering school in New York City, and an architecture school. So lots and lots and lots of technology there. And I come in, I look at it, and I realize, our engineering school, for instance, is over 100 years old. Those of you that are New Yorkers know about the Compton-Goethals Bridge. Goethals was one of our graduates and one of our faculty members. He's also the lead architect on the Panama Canal. So that's our history. We had never made any kind of a systematic attempt to commercialize anything that had come out of our engineering school in 100 years. And that also meant that our model, both in the sciences and in engineering, was, a faculty member writes a grant, does some research, publishes some articles. If they've got a spin-off company, they do it off campus for their own benefit. But basically, as an institution, we've never problematized what our role is in innovation. And so coming into this job, even as a political scientist with no background in this stuff, I thought we really got to start pulling together our assets in technological research. And so we looked at that a little bit. And in fact, one of the things we found is that we didn't have, either at the college level or the university level, the infrastructure to do this work. We were good at getting grants from National Science Foundation, National Institute for Health, but once the primary research was done, it kind of evaporated into the ether. In fact, one of the early conversations I had was with a guy who works in photonics, and he had developed a photonic microscope and got the patent, but the university which held the patent kind of let it go. 10 years later, hires a new faculty member who's doing kind of the same research. And he says to Bob, come up to my lab, I got to show you something. And what he showed him was the microscope that our guy had developed the prototype for. And so someone else had picked it up, commercialized it. And so this made me think, we really have to be a little bit more intentional about this. So that's in relationship to the research that happens in our labs. At the same time that was happening, lots of people became interested in how you develop entrepreneurship capabilities among the students. And so we had a number of grants brought in by a number of different people scattered across the college to build innovation centers and accelerator programs and incubator programs. And the idea behind all of it was these 18 and 19 and 20-year-old kids would be able to go through about an 18-month program, take an idea to market, make a bunch of money, share a little bit of the profits with the college, and keep that innovation ecosystem going. It just doesn't work that way. The amount of you look at somebody like a Mark Zuckerberg who develops Facebook and graduate, that's 1 in a million, probably 1 in 20 million people do it at that level. Most of the survivable innovations that go to market are people that have been out in the world and had developed some sophisticated approaches to problems that they've really kind of thought about. And so you get into innovators who are 45, 50, 60, and that's where you get people who are building companies and bringing things to market that have a reasonable chance of success. And so looking at that kind of landscape, we had to do a couple of things. First of all, we had to recalibrate what we were producing when we worked with undergraduates. And it wasn't that we were producing entrepreneurs immediately. What we were doing instead was teaching young people how to work the product cycle, how to prototype and product test and work in a design team with other people. And so rather than necessarily graduating the person who's going to launch PayPal and make, a couple $100 million, we were training students in how you work with bigger teams, which is a huge lack in the field. Being able to come into a multidisciplinary team where there's design people and economists and market researchers and engineers and scientists and play a role. It's hard to teach that skill in academic disciplines the way that they're segmented. And so we started moving in that direction. The other thing we noticed pretty early on is that the financing of these programs means that we could look across the campus and see about 9 different makerspaces funded by 9 different grants written by 9 different people that didn't talk to each other. And so pulling together all of those different capabilities and coordinating across funding streams and across original designs. So now our makerspace innovation ecosystem is very much like a public library system, where if I am a member of a program where we've got a 3D printer that does resins and plastics, and I need to do something in metal, I can be trained across the campus and move across the campus. And so we're training students to be as nimble as possible across those different areas. The third thing that we saw when we looked at the role of the university was that we weren't, as an institution, making a commitment to a certain field of endeavor. We were essentially letting the hiring processes of a chemical engineering department or civil engineering department in a way gather together people who may or may not collaborate with one another, or maybe collaborating with research teams at other institutions. What we're doing much more now is paying attention to legislation and funding patterns and the market, and saying, for instance, we need to build. So our engineering school now says our mission is the decarbonization of the grid, right? And so that positions them to hire a certain group of people with a certain set of skills, so that when, for instance, this massive wind power farm that's being built off the coast of New Jersey comes along at the Ravenswood facility and says we need to design brand new turbines, we have a collection of engineers that are prepared to do that. We have now a group of students that have graduated under their tutelage that are prepared to be engineers on that project. And we've developed in our workforce development program, a workforce development stream that allows us to train, what you'd call blue collar workers to manage, maintain, and sustain the technology being developed by our engineers. And I can tell the same, that happens to be the story or one of the stories in green technology, but we have the same kind of story in battery innovation and technology, the same sort of story in material science that feeds into opportunities opening up in this microchip legislation. So thinking about the college, the way it hires, the way it funds research, the way it puts research teams together in conjunction both with opportunities like the CHIPS legislation or the infrastructure bill and the needs of society is a new way of thinking for the college. And we're not, of course, a tenured faculty member can do whatever she wants as far as research is concerned, but what the college is doing is pulling together teams and incentives and connections, both downstream, upstream to funding and downstream to social use, to make this work. In some ways, this all culminates in a project that we are in the process of launching right now. We've secured the funding for, which is a City Innovations Collaborative, where we have secured resources to build a 36,000 square foot facility off campus that is going to focus on life sciences and biotechnology. And it is explicitly for bringing technology to market. So we have in our engineering school, we have a biomedical engineering program that about 10 years ago gave rise to a master's in translational medicine, which takes engineering graduates from that program, graduates of the medical school, economics graduates, and says, we're going to put you through a one-year master's program to teach you how to bring this technology to market. But then the next step for us is beyond teaching, actually doing it. And so we've got this 36,000 square foot facility that will be available for the task of bringing technology to market. And I want to say that we've also undergone a little bit of evolution in how we're thinking about what goes in that space. I think originally we thought, we probably need some genetic sequencing machines and some, wet labs and kind of classic life sciences research stations. But the more you think about the way researchers are networking into facilities and the need, even if you've got a physical facility, to draw in researchers from distance, we're moving much more in the direction of putting in some incredibly powerful computers that can do bioinformatics and analytics, as well as remote laboratory capabilities, so that yes, we will be renting space out in this facility for researchers who want to come to New York City and innovate in the life sciences sphere. And I should say New York City is making a pretty big investment in putting together other of these life sciences labs, but also developing the capabilities on that site where people who are stationed around the country and around the globe can utilize the computer technology and also the remote laboratory technology. And so our idea for this space is both that we will be now redirecting our scientists towards the idea of closing the circle on their innovations, developing it, figuring out what the innovation is, but then bringing it to market, either themselves or with a team that we assemble in that facility, but also making the facility available for innovators from outside the university who may need the computational capacities that we have, or may need some of the facilities that are set up for access remotely. And incidentally, would also have access to product development and design teams that are, comprised probably 80 or 90% of graduates of our engineering school and science school, science departments and the like. So that's kind of where we're at right now. It's a brand new thing for the college, but I think it's another step in positioning educational institutions to be relevant and necessary in technology and innovation. So I'll stop there, Lou, if that's okay.
No, it's okay. Vince, this is very exciting, as you know. For the audience, can you tell them how large CCNY's engineering school is, for example?
Yeah, we've got about 3,000 students. We've got about 120 faculty members spread out across 6 departments. I hope I get them all. It's civil engineering, electrical, mechanical, chemical, computer, and biomedical. And then there's some composite programs like environmental engineering that are composed interdisciplinarily. Yeah.
So, and in terms of the Innovation Center, what's the timing of this, and where's the location? You said it's off campus. So
it's off campus. It's close. It's there is, on those of you that are New Yorkers, on 126th Street, which is about 4 blocks south of our southernmost building. There's a building that used to be a bread factory. It used to make tasty bread. It's a tasty building. And it's recently been rebuilt with support from the state and the city as a purpose-built life science center. And we will be one of the anchor tenants in that building. We'll have a whole floor of that building.
Do you have a named director yet, or how is it?
Yeah. It's a guy named Jeff Garanish, who was the director of our Master's in Translational Medicine program, and now he's moving full-time into what we're calling SYNC, the City Innovations Collaborative. And we mean collaborative explicitly. Like the model will work by bringing in partners from local business, from government, from other universities. So we really see this as a hub. And again, if people know New York City, this tasty building is right in the middle of all of this new construction that Columbia University has done up around 125th, 126th Street. So the engineering school is right next door, their engineering school. Our advanced science buildings are the first building you hit if you walk north. And so it's about a 5-minute walk to our campus's science center, is about a 3-minute walk to Columbia University. So perfectly situated.
And fantastic. Thank you, Vince. Our next guest panelist is Eugene Francis. Eugene has been driven his entire life by the desire to learn as much as he can about as many things as possible. His passion has not been to just gain knowledge, but to gain a true understanding of the how and the why. This pursuit has exposed him to many industries, fields, technologies, levels, and sciences. Quote, knowledge can only be applied to that particular subject. Understanding, however, can be applied to so much more, end quote. It is this philosophy to which he attributes his success and continued involvement in problem solving, solution development, and identification of cross-industry applications and collaborative opportunities. Welcome, Eugene, and thank you for being with us today.
Thank you, Lou. Appreciate that. And thanks for the lead in, Vincent. This is perfect for me. So I'm going to go ahead and bring up a slide presentation here. Let me share this. If you give me a second. Okay, it's not going to let me share it. So just to lead.
No, hold on one second. Costa, is there anything that he should be doing, that Eugene should be doing?
There is a share screen button at the bottom of the screen. When you click on that,
But it's not showing me.
Have you opened your PowerPoint?
It's not allowing me to share. The share button is grayed out.
You may have to be given permission to share.
Yeah.
Try now.
Let me try it again. Yeah, no, it still doesn't. All right. Well,
Okay.
that's okay. So while he works on that, so
I don't have the same problem. So maybe you need to be issued a permission. Here you go. I'm starting to see something. Here you go.
There we go.
The permission is there.
You got it.
That's me presenting. Go ahead, Gene.
Okay, so there it is. So we'll just go with that. So so my background is in, like I said earlier, everything pretty much. My focus is on understanding the why, and when you understand the why, you can apply it to so many different things. And also on the collaboration side of it, and what Vincent had hinted to, is that I've worked for companies where bonuses were based on the revenue that you kept. So if you shared your revenue with someone else within the company, you lose that revenue. But if you subcontracted it out to someone else, then you get credit for that revenue, which seemed a little bit backwards to me. Also working in research and development, I've seen, PhD scientists spend 3 weeks to try and solve a problem that is not in their expertise, rather than picking up the phone and getting that problem solved within an hour by asking somebody who had the answers. And that was always something that I learned in management, was that you don't have to know everything. You just have to know the people that do. So, and my slide isn't advancing. I don't know if you can advance it for me.
I'm going to do it for you, Gene.
Okay.
I'm presenting.
So so when I was at the federal government, I started a forum that was focused on ideation and collaboration. I use the word ideation. I have innovation in there, but I think innovation has been abused as a word and given too many meanings. And the real focus is on ideation, and that's where your dual use and multi-purpose of technology comes from. So what we did is we focused on bringing not a single industry together, but bringing in people from all different industries. So that way, it's like the quality, like process improvement. So with process improvement, you don't use the people that run the process to evaluate the process. You bring people from the outside in to evaluate the process. They're the ones that are going to ask the questions. They're the ones that are going to want to understand what's going on. And they're the ones that are going to find what can be improved. So I took that same philosophy and applied it to this forum. I made it to where it was any technology, any capability, any service that people wanted to address, as long as it fit under the new, novel, and innovative categories. What we got out of that was people from all different industries coming in and watching a presentation about cyber, or watching a presentation about biology or microbiology or electronic warfare. And they started asking these questions and said, hey, have you ever thought of, did you ever do this? Did you ever do that? And lo and behold, we were able to identify multiple purposes that even the engineers that design these things never thought of. So in the 7 months that I ran this for the federal government, we ended up setting up over 400 collaborations. And that's 2 presentations per week for 7 months. That's roughly 50 presentations. We set up 400 collaborations. And to me, that number was incredible. If you go to the next slide for me, please. And the way we did this was, we had the companies present. It was an open forum, so anybody could ask questions. The presentations were set up in a specific way to foster communications. I would not allow people to put questions in the chat. I wanted people to ask their questions out loud. I wanted them answered out loud, because we need that interaction. It's that interaction that causes people to think. You ask somebody a question out loud, and they've got to process that in their head, and that's when the aha moments come. So these next 2 slides just give you an example of how these meetings were set up, these presentations. So you can see that, we talked about hypersonics, and we talked about using people having access to military sea lift commands for testing, because it's almost impossible to get access to a U.S. naval vessel, combatant vessel, for testing. We talked about radar antennas. We talked about synthetic inflatables. We talked about wireless power transfer, advanced antennas, surface wave communications, which is actually they have a way to communicate underwater. They can use any surface wave to be able to communicate. They can communicate using the layers of the different atmospheres and where they meet. So, and if you can go to the next slide, please. And then here again, 3D printing, this human systems integration, edge processing. Here's a company that came up with a way to use the Earth magnetic field for navigation to try and get away from the GPS. So we didn't restrict ourselves to any specific type of technology. And it was incredible, because the one technology that had the most participation of any presentation we gave was someone from Purdue University that was talking about fish surfaces. And the mucus on the fish surfaces, the scales, how fish are able to stay in one place in the current, all that kind of stuff. It was fascinating. And there were so many people on that call. I was amazed that would be the top one. I would have thought it would have been something else. So this was the whole focus. If you go to the next slide. And so now we started capturing this, and what do we do with it? We set up these collaborations, but then how do we track these collaborations? I was just one person, and it was next to impossible for me to track these 400 relationships that I had set up. So I was working to develop this. I've left all the blocks out because my IP isn't protected on this just yet. We're still in that process. But you can kind of see here that if you look at the blocks, we've got a sources for input generation, a corporate forum, a public forum, an R&D incubator, a limited access forum. So all of this stuff was to create an online collaboration platform where the individual collaborators would have their own protected entity on this platform. But at any time, if they ran into a hiccup, they could go out with an R&D incubator and ask a question and say, hey, you know, we're having this problem. Does anybody have solutions? And this goes into academia. This goes out to all the research labs throughout the federal government. We had people in Europe that were participating in this. So this goes everywhere, and it works kind of like a Twitter does, where people can contribute and they can add and oppose and promote. And so in the end, they end up with answers. They also end up finding collaboration partners that are part of the to be part of their community, and they also have the latest access to the latest and greatest technology. So this was the next step. But the sad part was I was shut down. I worked for the Navy, and this was a federally federal community. It was all across the federal government. There was over 150 agencies of the 250 within the federal government, and I was shut down for being non-Navy centric. I retired. That happened in March. I retired from federal service soon after that, and I've been trying to get this back up online ever since. But the value is there. There were a lot of people from the community that were helping me to identify a place for this, and we hope to be launching it again here in the near future. All right, if you go to the next slide. So that was it. That was all about the forum. I don't know if you wanted to ask anything, or Lou, if you wanted to talk about the forum at all before I get into the factory ship.
Well, let me ask you a question about the forum. Did you get any feedback of any of these 400, let's say, projects, whatever you want to call them? Have any been monetized?
Oh yeah, they'd been monetized, and I've actually developed a way to monetize the forum by using it as a patent factory, as an IP and patent factory. Also talking with some VCs that might want to use it or use the collaboration platform in their businesses. But for a VC to be able to identify the latest and greatest, I was working with all the S&T, well, not all, but a lot of the S&T organizations within the federal government, and they were sending me their requirements. We had several things come out of this. You know, there's probably a dozen, program of records that came out of this, just out of those 400. And that's good, because it usually takes a year and a half or something like that to happen. So
Eugene, you're going to try to reestablish this on your own, like this, with your own corporation, or what's the thought on this?
So
this collaboration partner.
Yeah. So the thought is that, we were bringing in academia into this. So one of the things that we were doing is we were working with the Naval Postgraduate School, and they were going to start having their graduates present their capstone and theses on the forum and market those for people to pick up. They were also going to be soliciting the forum for access to ideas for these students to come up with capstone projects that they could work and that they could sponsor. And because it was such a broad community, we were over 1,700 people, and I had 500 waiting to add. I didn't want to add them all at once because I wanted to try and keep my my growth steady so that I could keep my attendance steady. But we had that. We had people providing in-kind services. I had one group that was going to provide me with a funding fee because I was able to put them together with technology they needed. Other people were investing in the forum to keep it operational and to help expand it. I had two agencies that wanted to franchise it. I wouldn't just hand it over because I wanted some kind of control over it as far as organization and structure, so that it stayed the same quality that it was. So those were going to be franchisees. I had several corporate entities reach out wanting to participate, and they were interested in paying to participate. But the challenge was with the IP and non-disclosure agreements. If within the federal government, we don't sign non-disclosure agreements because we're bound by law. And if we divulge IP, we could go to jail. So that was a challenge that I would have to overcome. And I've talked to an attorney about trying to come up with some sort of a broad NDA that would cover the forum.
Yeah, Eugene, this is like fascinating, but please go on, and let me know when you want Cameron to come on board so Eric can introduce.
Okay.
Yeah.
All right. So if I can go on to the next slide. All right. So this is something that came out of the forum. This was actually my idea, and this is something that I am moving forward to patent right now. It's a factory ship, and it just kind of made sense to me because we have tenders. We have Navy tenders, which are ships that float out with the battle groups, and they're there to repair things. They have the expert technicians on board, and they can do the detailed repairs that the technicians on the ships don't have the capability to do. So why can't we do that with manufacturing? And the other thing too is when we have something break out in the field, it takes forever to get a part there. So if it happens on the battlefield, the next place back is a small temporary base, and then you get to a local country thing, and it could take weeks, months to get things. But if we had that capability there in the area of responsibility, it's right there. And so if you can go to the next slide for me.
So pushing the capability as close to the tactical edge as possible, as it sounds
Right.
like.
So that was the goal, is to move manufacturing as far forward to the point of need or fight as possible. And there's different ways to do this. We were working on things like roboticizing soldiers. So using AI to control a roboticized arm that did welding. So now any airman, any soldier could weld something, because all he has to do is put on a HoloLens and follow the directions of the AI. It tells him what speed to move, how to apply it, how far away to be, and it can also monitor that. So if he isn't doing it quite right, it can adjust it to be proper. So now you don't have to train everybody to be a repairman. You just have to train them to operate this system, and everything would be in the AI. So these were things that we were doing with that. We need a much larger platform. The Air Force was looking at using C-17s. The Army was looking at moving containers. And so why not take all these containers, come up with these manufacturing processes, and put them on a large cargo ship. This cargo ship could transit with a battle group. It would be protected. It could be manufacturing the whole time that it's steaming. And once you get it to where it's going, you anchor it in protected waters. One of the challenges that came up during this was, how do we get supplies in and off of this? Well, we found a hypersonic vertical takeoff and launch company that has a vehicle that can take off vertically, go hypersonic, deploy the payload at hypersonic speeds, and then once it gets back to the area where the ship is at, it'll go subsonic and land vertically again. So now if you imagine a cargo ship just has a big flat top, and you could have these things lined up all over the place, and they could be launching Humvee parts. You could also launch UAVs, UUVs, USVs right from the deck. And so that's where we get into the pilot. So if you can go to the next slide for me. So these are the people. See, this is what I love. See, this is what it's all about. I have an idea, but I don't know exactly how to do it. So I go to all the experts. I go to the Advanced Robotics Manufacturing Institute, which is it's a not-for-profit, quasi-government manufacturer. Tampa Deep Sea Explorers, Deloitte, Hellbender, all these companies, all these people here that I talk to, and together we take this idea and we make it a reality. There's no way I could do this myself. I need these people. So I am basically the facilitator. And so this is where my talent is at, is putting all of this together. Now, if we can go to the next one. So what we came up with is, here in Tampa, there is an old World War II victory ship. And you have one over in Greece.
You mean Liberty Ship, Liberty Ship.
Yeah, Liberty Ship, right. And so this is a museum. It's right on the water. And we came up with the idea and talked to them, and they're all for it, is that when you go in this ship on the museum deck, there's holes that go down to the lower decks where they would load cargo. Well, those are open. So then these 3 containers here would each be a manufacturing process. Now, for this pilot, they would not be enclosed. On a ship, they would be enclosed. On a factory ship, they would be enclosed because we want people to come into the museum and see it. We want to use this as a dog and pony, but they would still maintain their configuration here. And this is what we would do. We would bring in raw material, and then we would make from raw material a deep sea explorer, which if you can go 2 more slides for me, or that one there, this Barracuda. So this is what we're going to make on the pilot. And when we finish, they're just going to toss it over the side into the water.
What volume are you looking at?
I mean, on a ship, it won't be many. I mean, it'll be a couple, maybe a half a dozen a week, I guess, because it's just to prove the concept. We're not really trying to go and be a manufacturer here, but the idea is a lot of the manufacturing processes would be repeatable. Those would be fixed on the ship, on the factory ship. Everything else would be containerized. And if you needed Humvee parts, then you bring down those containers, you set them up, you produce a bunch of Humvee parts. Aircraft parts, same thing. You want to produce UUVs, USVs, you bring it down, you crank them out, and you put it back. You could also use it to produce energy while you're out there. And the beauty of it is it's right there. And so now at this point, I'm going to bring Cam in. So Eric, if you want to go ahead and introduce Cam.
Before you introduce Cam, I find this discussion fascinating, quite frankly. And the last panel discussion we had actually had to do with Hellenic energy independence, and we had some experts in energy. One of them was, very distinguished person involved in nuclear energy, and one of the concepts that he had was and he is discussing this with the government, is actually floating nuclear plants that can come into an area and produce energy for various countries. Okay, so I just find this whole thing like wow. Eric, take it over.
Before I introduce Cam, the interesting is I find so interesting. We're talking about manufacturing Ford, whatnot, tie-in with the Victory ship in Tampa, Liberty ship in Greece, which Lou actually was key to that even happening. And now we're sitting here on a panel talking about these things.
Liberty ships.
yeah, exactly. So just to circle around, Eugene and Cam are the ecosystem, I'll call it. Cam Hunt was drawn to applied innovation early in his career. As a creative generalist with a do-it-yourself ethos, he loves thinking big thoughts and then rolling up his sleeves. He has worked heavily in the defense and emergency response and do-it-yourself ecosystems. He now works to mentor younger generations, advise startups, and generally focus on paying it back. Cam, welcome.
Thank you. Thank you. It was a great opportunity to be able to present and be part of this panel, and so thank you in advance for that. I did meet Eugene through his innovation forum and was grateful to be pulled along on his factory ship concept, and more so that we were able to provide a kind of a Tampa-centric focus for that. And part of that is simply luck. We do have a Victory ship, by the way. This is nerdy for those who like history. There was both a Victory class and a Liberty class, so, merchant, kind of weaponized merchant marine ships. So the Liberty class is the one in Greece, and we have the Victory ship. Small modifications and fun to look up online to look at the differences between them. But both are serving the same kind of purpose, serving as both memorial and potential to continue to serve. And we also have this small company called the Tampa Deep Sea Explorers that make this very innovative underwater platform. And just out of sheer coincidence, the Barracuda is actually currently manufactured about 600 meters from my house as the crow flies by one of the gentlemen of the company. So I go on walks, and if I see his garage door up and he's in there assembling and doing the molding for the device. As we came up with this factory ship idea, we knew it was a good idea. We had good performers. We knew, like everything else, finding the threshold funding to move forward would be a challenge. We accepted that challenge and are pursuing it. But we also realized there was a chance to get started at a smaller scale immediately. And that's what led to what I'll talk about, the STEM-oriented idea, because I share with some of the other panelists here a passion to mentor and prepare the next generation. And my focus in my career has been on applying, hands-on work for things that matter. And so the idea that we're now starting as kind of a precursor to the full factory ship concept is still the same idea. Let's build this robot on a ship, and then once we build it, let's throw it over the water and operate it. And then let's get its operational data and sensor data and bring it back and analyze and then iterate. And the nuance with this now is we want to use undergrads, students to do the cycle, to do the building, to do the operating and doing the analyzing, with local professional mentors to come in and guide and shape them. The reason we find this compelling is because as we talk to students now, they're very much interested in understanding how the skills they earn provide them the greatest freedom of movement in their professional and personal lives. And so when we come to them and say, hey, this is a microcosm of anything you might find anywhere, no matter what the scale is, there will be people who are of course, design and build, people who operate and repair, people who analyze and understand and feedback. And we're going to give you that experience in a semester taste, if you will, using this thing that is very applied, very direct in terms of whether it's climate change, ocean thermal, which of course you could tie to climate change, understanding your natural environment, sea level rise, all those facets that many in this generation feel intuitively. If you go on social media and you look at this younger generation, they talk about financial fears, they talk about climate fears, they talk about, should I even have children because of what I see on my little slab of glass and plastic and metal. And I don't have the answers for them that would calm all of their fears. But what I do know is that by understanding and feeling like you have a way to understand, you can at least tone those fears down or right size them or fit them in. And so our idea with this is, yes, we're going to do STEM. They're going to be smart engineers. They're going to apply. They're going to put their hands on their technology. But a deeper element is that sense of autonomy, self-sovereignty, the concept that they can do things themselves to understand the world, have a better handle on it, and then make better decisions. And so from that, I'm going to tie and weave that into another thing. The reason the Victory Ship is so interesting to us is it's already participating in a smart city testbed. And so I'm going to transition now. We've gone from the forum, we've talked about the factory ship, and now we're going to talk about the smart city and how that weaves into it as well. So currently today in Tampa, there is a smart city testbed that is owned and operated by several small businesses working together. And each of the small businesses, there's 3 of them that lead this activity. They've each picked a different part of Tampa, and those areas touch each other. So on the screen right now, you see the little brick and kind of a downtown street view. That's a part of Tampa we call Ybor, our old cigar manufacturing district, historical district.
Cam, are you sharing slides?
Oh, I thought I was. So sorry, let me fix that.
No problem.
Maybe the sharing kicked off.
Yeah, it was the same. It was the end of my slide deck.
Okay. Can we all see the slides now?
I see them.
Great. All right. So again, we have 3 images across the top. On the left side of the deck, you see buildings and streetlights, and it's obviously a time delayed picture. That's Ybor. That is 7th Avenue. Ybor in Tampa, our historical district. And the business owners have gotten together. And where this whole testbed came from is the various business owners said, hey, we want better insight into this very popular environment. On the weekends, it's packed. We've got young kids, old kids. It is a real mixing pot that only kind of a unique entertainment area can provide. And because of the different mix of people, the different things going on, we don't want to have a heavy police presence. We don't want what we think of as a post-apocalyptic surveillance, society. We don't want cameras everywhere staring at people. We don't want heavy police, but we still want to know when things are going to happen. And so they started a discussion, and I was fortunate to be part of it, of exploring a way to understand your environment while preserving the privacy of the individuals, while looking to be upstream of any bad effects happening, whether it is a fire, a shooting, a mugging, anything that we can see. What are the ways to understand that environment and get ahead of it while preserving the privacy? And at the same time, another company came up and they set up on the American Victor ship, and they said, hey, our customers are interested in smart ports, and what can you do to give visibility into a port, not just from our traditional post 9/11 security framework, but environmental concerns and economic concerns and dual use. And so that center image is Port Tampa Bay. Now, what's interesting is we see the big cargo ships and the ship repair docks. There's also a cruise ship, but there are many recreational ships that come up just because they want to go see the port. So if you actually go out to the Port of Tampa and sit there and watch, you'll see a huge diversity. In some areas, you'll actually see people on paddle boards. You'll see tour lines. It's an incredible diverse set. And so that's like, hey, we want a more nuanced understanding of how is this resource being used, and how do we better adjust for all of the various stakeholders there. And so that smart city testbed is focused on that kind of port marine view. And then to the far right is also an interesting mix. And again, these are all contiguous. So Ybor is in the northernmost point, and as you get to the bottom of Ybor, that's when the Port of Tampa Bay starts. At the very bottom of the port is the inlet that leads right into where this airport is, the Peter and I Airport. Now, what you'll notice about the airport is it's not just an airport. The airport's next to a little marina. And this is a very popular part of Davis Islands, where people will come out and they'll walk their dogs, they'll look at the boats, they'll hang out. And then it's also a small city airport. And so we've also looked at, well, what does a smart airport look like at a micro scale? And so that makes up the constituent parts. Now, what are we sensing? Well, of course, we have cameras. You've got to have cameras. There are also motion detectors. There's radio frequency sensors to understand the diversity of a spectrum that most of us don't even think about. But increasingly, as we have more kinds of devices, that becomes contested, not just with cell phones, but Wi-Fi, Bluetooth, and all sorts of diverse things. And last but not least, there's also a cybersecurity element. So how is information flow? And I should say with cybersecurity, we could say cognitive. How is information being reported? Are there bad actors in the information space operating here? And it turns out there actually are. So one vignette I'll give you is I was supporting an exercise with some of our military partners who are coming in and using this as a training environment to understand how they might be vulnerable to smart city technology. And during the exercise, several of the military members came up to me and said, hey, we had something suspicious go on. We started getting phishing text messages. So text messages coming in with links that they didn't click on, but they handed off to their security people who said, yeah, this link, if you clicked on it, would have tried to infect your phone. We had one of our engineers come out and say, yes, someone is running a fake cell tower illegally in Ybor and using that fake cell tower to pick out the identifiers of phones and then using those phone identifiers to then submit this information to. And so that was obviously worrisome, but it's one of the reasons we do this, is to help understand what kind of threat is going on in the environment. The little image at the very bottom is a mobile application called CivTac. And CivTac, or the Civilian Team Awareness Kit, has become really popular as kind of an interoperable tool for different stakeholders to share information about events or environments. And so what's really nice about what we've done with this testbed is, even for the purpose of pure testing, the data, the information can be passed now to various stakeholders. So we have stakeholders in the city government, not just the police. We have government stakeholders, of course, in business. We have some academic partners. And of course, many of the business owners themselves who are part of this want to see what's going on. And so this is an emerging concept that we wanted to share here because it's becoming an engine for now learning about data. We have people learning cybersecurity in the context of a real environment. I mentioned the military and the security side. We also have environmental interests looking at this. And it's still kind of amorphous because it's not a single funder and a single entity. It's kind of a loose collaboration. And so we are not sure where it's going to go in the future, if there's going to be a dominant interest come in. But so far, at least at the end of this year, this environment is providing a lot of value to the various stakeholders using very inexpensive equipment, very strong and stringent privacy concerns, first and foremost, and that companies that own the sensors are the first line of defense. They're the first ones who make sure that images and license plates or any personal identifying information is scrubbed from the system and kept away, because that, again, that's not the intent. It's about awareness and understanding. Go ahead.
It's interesting to me as you say this. I'm, as you're sure you probably know, you're aware of JADC2, Joint Underpinning Command and Control. Has anyone approached you about that? What lessons learned that apply? You have this feedback loop and command and control, almost responses, and this essentially a multi-domain environment, but in the dual use civilian sector, right?
Correct. On the military side, so when we talk about JADC2, that is primarily and predominantly focused on major traditional military systems. That's where the bulk of the focus and the money is going to. And unfortunately, I have to say to my military and government brethren that they still tend to be focused on a capability, a device, a particular function. It's right. It is difficult to fund and sustain systemic views with multiple partners. And so certainly there have been many informal discussions about it, but so far we have not yet seen a funded effort explicitly for this civil military kind of interoperability. Yeah.
Interesting.
Yeah. And so at this point, this is really kind of the end of my presentation. So I will turn it over to, if there's any other questions or comments from the panel.
Well, we'll come back to that later when we have like an open discussion. Yeah. Eric, you want to introduce our next panelist? Thank you, Cameron. This was fantastic. Amazing stuff.
Absolutely, and I'd like to really thank Tom for coming. We met under interesting circumstances, so I'm very grateful he's come on to our panel. So I'm about to introduce Tom Katsoulias. Tom has years of experience in EDA, and if you're not a computer engineer, I'll mention what the acronym is: electronic design automation, semiconductors, electronics, embedded systems, software, and Internet of Things applications. Tom is currently serving at the U.S. Department of Commerce IoT Advisory Board in connection with the Digit Act. He is the CEO of Archon Design Solutions, a consulting firm focusing on public-private partnerships and ecosystem strategies for trusted supply chain traceability of electronics and IoT devices. Most recently, Tom was the board chair of the GSA Trusted IoT Ecosystem Securities, and GSA is Global Semiconductor Alliance, a collaborative group of companies in the IoT value chain promoting end-to-end solutions for various vertical markets. Prior to the GSA, Tom led the trusted chain business at Siemens, focusing on chip supply chain provenance, traceability, and security, starting from IC manufacturing, test, as well as IoT solutions for the industrial edge. Tom has held executive senior management and engineering positions at Digital Equipment, Cadence, Synopsys, Amocore Technology, and Forte Design Automation. Tom holds an MS in electrical engineering and computer science from the University of Massachusetts at Amherst, a BS in computer engineering from the University of Bridgeport, Connecticut, and a certificate on IoT business implications and opportunities from the MIT Sloan School of Management. Welcome, Tom. Thank you for coming.
Thank you, Eric. And Vincent, when I first came to the US in 1980, my first semester was in City College, upstate New York. before I moved to University of Bridgeport, I have some good memories. So let me tell you a little bit about my journey. When I first came to the United States, I basically got my bachelor's at University of Bridgeport, my master's at the University of Massachusetts, and then I worked for digital equipment, and I was lucky enough to work on any engineering discipline you can imagine, from chip design, manufacturing, system design, connector systems to the DECnet, because before internet existed. So I was fortunate enough to learn the entire supply chain because I participated in each and every engineering discipline. Then I moved to Silicon Valley, joined the company Cadence, and I basically focused on the design automation and design automation workflows. So I'm very, very big on productivity automation. So if you have 3 tasks in the workflow, A, B, and C, and A and C are very fast, but B is slow, the whole workflow is slow. So I'm very big on optimizing workflows. And then I made a career in Silicon Valley, but I was also involved with the Silicon Valley innovation ecosystems. And around 2009, I was involved with Greece, where basically we built the first bridge for innovation ecosystem, starting at the Stanford University, where we held essentially a dual, a dual force consortium between Greece and US, one CEO for each place, one VC for each place, one lead of technology, one university professor. And at the time, we put a panel saying, why Taiwan and not Greece? They're both too small. Long story short, this was the very first attempt to create an ecosystem a la Silicon Valley, which had the elements of government, academia, VC, and industry. And that created essentially a number of LinkedIn groups between Greece and the US, and also other places in the diaspora, which evolved over time. At that point, the Katsoulias gave me an assignment to investigate the liaison offices on the Silicon Valley and how they collaborate with their home countries, Norway, Denmark, Sweden, and so on and so forth. Long story short, I talked to all the TMs. An innovation office in the country of the Silicon Valley is like a field office where the government basically gives all the orders. And their words of wisdom was, if you want to do something like that in Greece, you have to have a national commitment. You got to have funding sources. You got to have legal structure, governance, and of course, a Silicon Valley operations that rounds that up. And at the time, I was exposed for the first time on how these things work. There's the Foreign Direct Investment Model, FDI, where is a national program promoting resources to attract investment in your country. These days, Greece is very successful in that. They brought in Microsoft, AWS, Tesla, and so on and so forth. Promoting low-cost labor, not anymore. Now it's about innovation. Then the other model is the outbound innovation investment, where you have a lot of startups that essentially have an idea and they come to Silicon Valley for funding. Those are very good models, and they've been applied today, except the first one essentially is good for building infrastructure, but it absorbs the talent. The second one, whatever talent is remains, they're trying to build a business, but they get funding from abroad. So when they exit, the money goes somewhere else and not in Greece, and the talent as well. But the ones that were more interesting that have not been implemented yet, that I learned from companies like Sweden that had Nokia, etc., was the foreign indirect investment, whereby you have a small innovative team, innovate a pilot program in the home country for a small population, and then once they prove it successful, they give it to the big company to take it global, and they get a cut of the proceeds while it scales, which is a very good model because, you can basically prove it very quickly and then scale it up and share to the reward. And of course, the other one is the inbound operations investment, where basically a company like Pfizer comes and puts on operations in Greece. They've done one in Thessaloniki, and they built innovation centers, which is also very good. So all those were essentially unknown models at the time. The only thing that existed were startups, a lot of them. And I ended up helping a bunch of them, starting from chip design all the way to IoT. There was growth, very unstructured growth. We call it the innovation eco islands in Greece. And it also happened that we also had the brain drain. It was a very bad period of time. But 4 years ago, that started changing with the new government. And they started looking at a very modern ways, the Harvard business ways, if you will, of building the nation, and evolving the new Greek innovation ecosystems with essentially a bold vision, a national commitment, legislative actions that are broadening out ecosystem platforms. We're going to talk about that with Eugene because he is on my hot button here, whereby you bring together the government, the private sector, and the academia. And of course, a collaborative network. That was kind of the thing that got me really interested. In around 2016, I was involved in a project about building chip security. And that during that time, China bought the port of Piraeus with Costco with full control. And in that port, you get the railroad that is the artery that supplies the entire Europe. Okay. And that caught my attention at the time. And I did some research and I realized that the Chinese were doing that with other ports, which was basically a very strategic view under the hood. Nobody understood it at the time of trying to control supply chains, notwithstanding the manufacturing competency that it brought in a variety of goods. At that point, I became vicious to not only care about chip security, but also supply chain resilience and supply chain security. We're lucky enough for our company to be bought by Siemens, who is a big conglomerate. And I went to the other side of Siemens to look how they basically put devices in factories, what is the security, what is the supply chain, and I realized how naked the world is. Because on the one hand, you have big enterprises that have silos BUs, not connected with one another, all right? Claiming innovation, and they innovate within the BU, but within the very strict accounting barriers. On the other hand, we had the same problem in the supply chain because when you look at the microelectronic supply chain, it's very disaggregated, and there is not such a thing as security because the attack surface is so vast that unless you build a very tight, trusted collaboration ecosystem, there's no way you can ever have supply chain security. And long story short, I learned a lot of things from Siemens. As a result of that, I went to the Global Semiconductor Alliance and I assembled a bunch of companies, approximately 40 companies across the supply chain continuum, and 100 contributors trying to work this idea of collaboration at an ideation and promotion stage. We would not implement anything in the GSA. We would facilitate partnerships, though, that could nurture themselves outside of GSA, subject to essentially providing templates on the teams to build end-to-end solutions and do different things. So fundamentally, we took a big salami called the supply chain, we sliced it into small slices. Each slice would be a bunch of experts with domain experts, and eventually those domain experts will basically propose solutions end-to-end from in the domain, from the beginning of the domain to the end of the domain. And then you kind of stitch them all together to create what we call a trusted IoT ecosystem. And that's what the name came up, Trusted IoT Ecosystem Security, ties that can be that can grow and scale only with trusted ties among the participants. Long story short, we started actually creating a liaison group, talking to all the standards bodies. We realized the supply chain problem is a huge problem with the standards bodies, too many fragmented standards. You know, we didn't need more. So we wrote a strategy document as a result of an RFI to NIST at the Department of Commerce. And this was about a strategy of how we can actually build a resilient and trusted supply chain in a way that incentivizes companies to participate because they're monetized. That's the last part is key, because security is something that everybody wants. Nobody's willing to pay for, except DoD, by the way. And when things break, everybody blames everybody else. So the question was how to actually bring it to the masses, how to make it to the commerce, right? And as a result of that, I was appointed by Gina Raimondo to serve on the advisory board for IoT. And the IoT basically tackles a number of subjects such as smart city infrastructure, smart cities, smart agriculture, supply chain, and so on and so forth. And I'm co-lead security, and I'm co-leading a bunch of those, but I lead the supply chain group, all right, the supply chain subcommittee. And with that, I would like to share some slides on what is the concept that we're trying to promote, which actually uses a lot of the vectors that I heard from Vincent. How do we build a multidisciplinary team and start from academia so that when those people go out, they're ready and not just interns? Continues with the ideas like what Eugene presented, which is, how do we go create a collaboration platform for ideation? And that ideation enables people to start collaborating and developing governance, etc., that will lead ultimately to implementation that can be tested in an environment such as the one Cameron described in a smart city. So if you think really about it, all right, the pieces can come together, but we got to step out of the box and look at this as an ecosystem. With that, I'm going to turn off my video so that she doesn't describe the slides. And I'm going to go over the slide deck to just give an idea of what we're doing at the IoT Advisory Board. Okay. Okay, here you go. Can you see my screen?
Yes, we can see it, or at least I can.
All right. Now, this is my opening slide deck in the IoT Advisory Board that was given in my name day on January 18th. And we modified a little bit to factor the DoD synergies with commercial markets. The reason DoD is important, and it was not covered initially, is that DoD accounts for about 1% of all the microelectronics sold worldwide. So in other words, it's not the most important customer, but it's the most security sensitive, trust sensitive sector from which we can learn and bring concepts back to the commercial. So the main message was that IoT will explode in ways that are transformative for our planet. We're going to have 100 billion devices, 500 zettabytes of data by 2030 that will drive tens of trillions in economic growth, but would require changes in infrastructure for connected IoT value chains and marketplaces. The growth of IoT is impacted by two major factors. And by IoT, I define it as any connected device or system, or systems of systems, by the way. The growth of IoT is impacted by two major risk factors, global supply chain imbalances and vulnerabilities. We all experienced them during COVID. And of course, microelectronics value chain impacting the security of the IoT devices and data that comes out of it, because you don't trust the data, you don't, get enough security, you got a problem. And data is the new gold. And it's the new gold that will drive every ML and AI application. So if we don't really look at how do we get the supply chain before we get to this connected ecosystem planet, then we're not going to have ever security. So we must take actions immediately. With international allies. This is not just a national security, it is international security. This is why Gina Raimondo is talking to Thierry Breton from the EU, recently talked to the Japan Prime Minister, and is trying to line up 14 countries from Indo-Pacific on the supply chain issues for microelectronics. This is huge. This is very important. The whole world is mounting around it. And there's an opportunity for DoD, which tends to be a little too legacy in its processes. You take an airplane, for example, there's a 40-year life cycle for a fighter airplane or something, and the chips or the legacy chips are replaced maybe every 10 years. Well, the Chinese are doing it every year. So we really need to think through how we can basically get the DoD to scale up very quickly as the commercial sector is scaling up. And because DoD represents only 1% of the microelectronics revenue, and cares about the security, while the commercial sector cares about smart infrastructure, selling more devices, analytics, and so on and so forth, and applications, services. There is an opportunity to actually bridge the two worlds. And that opportunity is that IoT is so complex from a supply chain to a supply stack, meaning from hardware to firmware to software to hypervisor to edge applications, that it requires collaboration across multiple people in multiple disciplines, and therefore it is an opportunity for the world to start collaborating together. So supply chains, trusted private networks, and essentially could lead to IT service and data marketplaces. So very quickly, this growth of IoT is basically going to be augmented by the US and EU CHIPS Acts, 52 billion for the US, 42 billion euros for Europe, and that will fuel the semiconductor industry from 600 billion today to 1 trillion by 2030. And all those semiconductors will be fueling IoT devices, 125 billion of them. And those devices are going to be churning so many zettabytes. It will be very interesting to see how we're going to manage all that growth. In fact, in the recent reports, the problem will become an energy problem because the growth of data and the growth of applications is so substantial that the energy consumption right now is going to become a problem. It's not a Bitcoin energy consumption, it's actually IoT energy consumption. And then you look at what McKinsey said, that basically said in 2014 that it would be a 21 trillion, it will be projected between 10 and 20 trillion addition to the global economy. They were wrong because they underestimated the lack of collaboration, which cannot, this IoT cannot scale without collaboration. So they did a revision recently, whereby they resegmented the whole market, said the market is going to change. It will be settings. It will be factories, health, work cities, retail, and those settings will be fueled by collections of IoT devices working together. And as those settings change, we need to start thinking how the whole workforce and labor would have to basically start operating. And really, if you think about, the different things that IoT will enable, our job as an advisory board is to convince the big VC, the United States government, and of course, a lot of private parties to and global allies to invest in IoT so that we can actually fuel the growth in those different settings. And if you think about, the analyze IoT connectivity, complexity, and distributed nature in each and every one of those disciplines, all right, then you can start thinking about opportunities and risks that vary. The next thing is also, if you start factoring the supply chain, you start realizing that the ecosystems are connected, and they're all connected with MLA applications. You're going to go to the smart agriculture, you're going to get your crop, you're going to put it into a truck, you're going to get it to a city, or you're going to get raw materials for smart energy. All that is interconnected, all right? And if one part is insecure, untrusted, or slow, everybody becomes insecure, untrusted, or slow. That goes back to the workflows that we talked about. So then we start looking at the very basic business motivations of what an IT ecosystem is. And this is from Harvard Business Review. They've done an excellent job to talk about what we call smart connected products and how they're transforming the competition. The bottom line is, whether you talked about a connected tractor or a connected something else, we'll talk about it in a minute, but we're starting at the lower level of complexity, which is a connected tractor in the field, right? IoT is changing products and businesses through a typical evolution from simple products to smart connected products to smart connected products and systems, all right? This actually follows a classical technology adoption cycle of selling, which starts with innovators, early adopters, early majority, late majority, and of course, laggards that usually come after everybody else has proven the value proposition. The IoT connectivity helps accelerate adoption. Smart connected products not only shape competition within industries, but expand the industry boundaries, and we'll see in a minute how. The basis of competition shifts from discrete products, and here's a tractor with a dashboard that is a little smarter, versus the one that is connected to Wi-Fi, versus the one that basically is connected to farm equipment, along with like planters and tillers, right? So the basic competition shifts from discrete products to product systems to systems of systems, and systems of systems evolve into platforms. Here's a platform. You got a tractor with a farm equipment, but once you start adding humidity, temp sensors, field sensors, irrigation zone, weather data system, irrigation system, weather maps and forecast, and farm database analytics, that becomes now a connected platform. Well, guess what? If you start organizing, structuring IoT this way, the same thing applies for an airplane, which is much more complex and much more critical in terms of functional safety and everything. You still have to have an aircraft system, and then you got to have your weather system, your navigation system, and maps and forecasts, etc. All right. So now this is actually very interesting. I provided equipment that are essential in the supply chain. then you can actually start thinking about the same thing for trucks, trains, planes, automobiles, and ships. All right. The difference, though, in the classical supply chain is that it's sequential. All right. And it goes from one equipment to the other, and it's traceable to the extent that you can digitalize the workflows. When you go to the workforce system, you know, there's a lot of similarities, except the workforce system is much more dynamic. It's not sequential. Everybody communicates with everybody. There is, you know, the actions are real time, not necessarily historical. Whereas in supply chain, you can look at historical analytics and see how productive or resilient it is. But fundamentally, there is a lot of commonality with the rest, and that's where the dual use chips apply. All right, because now all these chips basically are used for the commercial market, but they're also purchased in the DoD market. The real problem here is those equipment, those devices, how often they upgrade the electronics infrastructure. Sometimes you can just leave the chassis to be the same, but have a more aggressive program of upgrading the electronics infrastructure, which will make you more competitive. And that basically brings us to, how do we create a strategy that is uniform across different marketplaces, where this is aerospace defense, automotive, wired applications, wireless applications, consumer, agriculture, etc. And it boils down to the fact that if you have settings, all right, like the smart city, and environments like the smart city, right, there is the bottom, which is, you know, criticality in infrastructure. This is the barrier, the infrastructure, the interoperability, the security for end to end is not there. You got essentially consumer being more advanced in security than industrial, right? For example, consumer has a 2-year life cycle, industrial has a 10-year life cycle. So therefore, the rate of upgrades and the ability to create a coherent ecosystem is very diverse. And then you get the top, which is the end application drivers for value creation. So what Cameron said, I got the smart city and I'm adding applications to it. All these applications, whether this is a car approaching a smart meter or smart parking and a monetization event occurs and the gate opens, etc. All those are new opportunities for monetization that require ecosystem collaboration. Because in a parking station, you're going to have an master PC that will open and close the gate, but in the car, you need to have the ECU smarts that will connect with the IPC to open the gates and then connect with the credit card system and the owner of the vehicle to essentially create a monetization event. That is 3 or 4 different disciplines in an ecosystem that can create this particular solutions out. So the methodology that we propose to be consistent in how we evolve this is that for each sector, consider how IT technology changes the environment. We're here today. What's the vision for tomorrow? We analyze the end market barriers, the drivers to evaluate opportunities and risks, assess how collaboration can enable innovation and scalable businesses, and that assessment requires an ideation phase, and plan to protect innovation, talent, IQ, and value creation from adversaries. Bring people in, not let people out. And of course, the last part is to orchestrate trusted networks and platform-based business ecosystem. What Eugene was talking about, but we actually organize and orchestrate the platform to facilitate a business ecosystem, which has an implication of governance, because you're going to have competitors in the ecosystem, is implications of processes and how you're going to run it, and how do you allow certain things to happen versus others not to happen. So this captures the end-to-end picture. Before we get there, supply chain starts from chips. People put Trojans. People basically get untested chips to gray markets. They create counterfeits. They put them into boards, and then they steal the IP. Or if they don't do any of the above, by the time you get to the OS after the board, they put hacks and malware. And of course, DDoS attacks is very, very easy to do if you have vulnerabilities that came back from previous supply chain. The problem is that supply chain is disaggregated. Over 65% of electronics are assembled, this PCB or heterogeneous integration, in Asia. There is ineffective sanctions and customer controls. And of course, when the problems occur in the field, it creates, it's very costly, creates liability, creates loss of value, it creates loss of brand. But even worse and more important is a critical infrastructure. Cameroon cannot have a smart city without having a trusted critical infrastructure that fuels it. All right. And unfortunately, if you look there, there's no policy to distinguish between consumer IoT and industrial IoT. There's no policy for systems and process sensors. We're tend to be kind of in the Stone Age. All right. There is silos and no visibility on IT versus IT connectivity. It doesn't make me good if I have a nuclear power plant and I have 20 secure IT boxes, but the 1,000 PLCs that run it are insecure. Doesn't work. So this leads to compromised equipment and human safety. Therefore, lack of supply chain traceability, not just visibility, threatens national security and economic prosperity. And I would add international, not just national. I'm going to skip that in the interest of time and go to the what is required to be done. If you look at the evolution of communication before we get to connectivity, it started back in ancient Greece, where a marathonian ran 2 hours to the stadium to basically spell the word Nenikikamen. We won. All right. That was the communication back then. It was very manual, very, or birds with the messages, etc. Until we got the newspaper, then we got to the telegraph, then we got to telephone, radio, television, internet, and suddenly you got Twitter and Facebook that built multi-billion-dollar valuations in less than a couple of years or 3 years. All right. This is very, very important. Of course, it's very easy to build such a valuation when you don't have a legacy infrastructure such as microelectronics behind you. All right. So it's very easy to do that for, in 3 or 4 years. How do you actually scale up in IoT in the microelectronics infrastructure? And we have to look and understand how it evolved before we actually talk about that. When I started my career as an engineer, we offered complete products. We had sales channels. And I was an applications engineer support. The sales guy would knock doors and I would basically go sell the product, demo the product, very manual thing. Then it came the disaggregation of the value chain, the web interfaces. So products now are being configured with the web. There's more complex support. You still have to have direct sales sometimes until you got essentially the internet commerce, where fundamentally the enterprise automation and the open source models start changing the way people operate it, starting from commerce to SaaS, software as a service, platform as a service, infrastructure as a service, to the latest and greatest platform strategies, which basically boil down to 3 types. Innovation platforms, such as Apple, Google, and AWS, which is an architecture and you build apps on top. And everybody who comes in basically gets to monetize leveraging the platform. And of course, the platform provider monetizes the most and builds multi-billion-dollar valuations, or even trillion in the case of Apple. Then transaction platform, where you own no assets whatsoever, but you facilitate exchanges such as Uber, Airbnb, and Amazon Marketplace. All right. Those are very successful platforms that, were built on top of internet, if you will, and on top of hardware architectures that create monetization. But there is no yet any collaboration platform to connect the value chains. In fact, there was one attempt by IBM and Maersk, the largest company in the maritime sector, to create what we call TradeLens. It was, they spent about $3 billion. And the idea was to be a platform to enable the maritime supply chain, but they failed doing it miserably and they called it off because they could not attract the participants in supply chain. And the reason for that was because they didn't make it open. They just make it closed. IBM and Mark said, we're going to monetize for ourselves. And everybody else is basically somebody who does not monetize the platform, but provides fuel to the platform. Flexport raised $2 billion to do similar things. That remains to be seen whether it will be successful. So collaboration platforms, basically in the electronics and microelectronics supply chain, is talking about virtual reaggregation of the supply chain, because you cannot, create IDMs with the exception of Samsung and of course Apple and Google evolving that way. The rest of the supply chain is disaggregated. So creating IT value chains with a digital data thread so that the digital data thread can be used both for tracking things and tracing things, but also for the ability to monetize that data coming from different places. And if you can actually do that, then you can create what we call data marketplaces, data consumers, and data producers, and everybody wins, not just the hyperscalers. And that's the thing that we kind of tested in the Global Semiconductor Alliance, whereby we built a collaborative ecosystem consortium of about 40 companies and 100 contributors of different disciplines and domain expertise, from chip to system to edge, okay? And then we said everybody has to follow the same governance of, you got, whatever you describe as solution, you got to describe your gazintas, your workflow process, and gazaras, and how you can digitalize that. And you own the data of digitalization, you keep it to yourselves, but the only requirement is that you create metadata identifiers. Cameron talked about those identifiers, all right, for each and every step of the data that you promote outside together with information, so that somebody downstream the supply chain says, oh, gee, I bought a chip for my airplane, but I don't want to test it again. The test data exists from a foundry. I can see that they have it. Now I can call them up and actually create a private transaction to buy it, as opposed to spending time and engineers to do it. Okay. And at the same time, the digital thread of these green arrows allows, if you do it cryptographically, the handoff being cryptographic, to essentially start mitigating against all these vulnerabilities that are coming through. And if you actually do it right, where the provenance starts at semiconductor design and manufacturing, and then the digital thread continues across, then by the time the digital thread is built, then it will enable what we call the digital transformation of OEMs, which is, instead of being IoT device suppliers, they're becoming connected suppliers to the ecosystem via their devices. And through that, if the digital thread is trusted, you get the trusted data, and that trusted data can be fed back to the ecosystem to create what we call trusted digital twins of chips, of PCBs, of designs, of software, or what have you. And of course, all that requires a very sophisticated taxonomy of standards, all right, and also regulations. So the CHIPS Act for the US and EU becomes a driver to essentially start this digital thread provenance. The cybersecurity labeling program that was announced by the White House, and it will be touted this July very soon, whereby you put a scannable code on a device, you scan it, and it gives you history of who, when, how, very important for traceability, is going to start rolling out for consumer IoT next year, and for industrial IoT soon thereafter. And of course, the Digitact for IoT, which is the advisory board that I'm participating, which essentially look at the future strategies from smart cities, infrastructure, agriculture, supply chains, etc. All right, quite often going back all the way to the chip. So this ecosystem, which was an ideation and promotion ecosystem, we had to create collaboration rules, some governance rules for shared success, and a set of interactions to broaden the IQ. Because when person with expertise A matches with person of expertise B, suddenly innovation occurs. And there was certain rules that everybody had to follow, because some people basically want to get the juice and go do it for themselves and compete with their competitors, whereas the subjects being promoted there were the ones that are very common, like security, traceability, etc. And the question really is, how do we scale the ecosystem? How do we make it an implementation, whereby traceability establish a market preference that will require some government statement to say, if you do certain things for traceability, you will have market preference. And if you are SMIC, which is excluded, by the way, by NDAA law today, that was passed in December, they will never have that market preference. The digital thread, to enable essentially a set of data producers from chip to PCB to system to etc., and data consumers, but more importantly, the monetization have to align incentives with public-private partnerships to drive behaviors with regulations and standards together, all right? And that spells out a very different set of private-public partnerships, because as opposed to doing the full banana of the supply chain, you slice it, you organize it, you orchestrate it, and you got a bunch of horses running in parallel. So if one of them does not or even falls, you replace it. That's a classic courageous strategy here for VCs in Silicon Valley. So there's an evolution: collaboration, innovation, transformation, platformation, and then scaling, all right? And if you think about it, if you actually do it on a small scale with proof of concept projects, you can actually see and develop the rules of how this can work and scale up in a way that can create, multi-billion-dollar companies. In that ecosystem of 40 companies, one of them actually made it to the platformation stage. So in other words, they had a specific capability for flash memories that they built an ecosystem around it, and a platform-based business ecosystem, and they were able to access the end market with their partners much faster and grow the business much faster because of that platform business ecosystem, which is no different than what Apple does and everything. So the top 5 platform companies, which is basically Apple, Microsoft, Google, Amazon, and Tesla, their value declined from 6.7 trillion in 2022 to, in early this year. Now it's up again. It's probably back to about 8 trillion or 9 trillion, but it's still a major portion of the $17 trillion GDP. Any platformation of any enterprise in the IoT value chain will multiply revenues and fuel ecosystems. Platformation creates the seed for creating companies like the top 5. And supply chain traceability across connected marketplaces can fuel growth with measurable ROI, and the way you measure it is in growth in manufacturing supply and growth in businesses offering IoT services or data-enabled ML AI applications. Bottom line is that with orchestration, regulation, and massively parallel private-public partnerships can enable the $21 trillion value, global value, and those partnerships can be cross-country. They don't have to be just in the US. This is where the international collaboration is very important. Thank you.
A lot to chew on, man. A lot to chew on there.
Yeah, of course, my background's computer engineering and software. And I first talked to Tom, he gave me a briefing, and I said, I get it, but a lot of stuff.
No, this is a lot of stuff, and collaboration is always complicated, quite frankly.
Exactly.
Especially when you have government-to-government type things, regulations, whatever. But this is a fascinating, very fascinating discussion. I'd like to introduce.
So there's a lot of stuff, and I would like to add that we're taking this and we're decomposing it to chunkable bites as part of the recommendation we're going to give to the Department of Commerce. But this lot of stuff is being tested and proven to be viable. That's the point.
Okay? Oh, absolutely. That's the
key. No one is arguing that. It's just fascinating. I'm just going to ask you one question in terms of the name of the company, Archon. Why did you put Archon there, just as a curiosity?
Because it's from the ancient Greek word Archon, Archondas, which was the chief magistrate of Athens that was orchestrating all the functions of the city, from dancers to artists to philosophers to engineers to everything.
No, I know. I'm just testing you. That's all. I'm just testing.
It's symbolic because the type of proposal we're putting together requires a lot of orchestration across many domains and disciplines.
No, of course. Thank you. Our final presenter is Stavros Messinis. Stavros is a serial entrepreneur and entrepreneurial activist and co-founder of Smart Flying Machines and an angel investor based in Athens. Recognizing that innovation in the Hellenic defense industry was lacking, Stavros put together a team of innovators to deliver solutions in the UAV space, utilizing rapid prototyping techniques and concepts from the startup world, such as fast iterations. Smart Flying Machines delivered a working prototype within 3 months. He is currently focusing on business development and fundraising for Smart. He is the founder of the Cube Workspace, Athens' largest co-working community, which hosts some of the Hellenic Republic's best technologists. Since founding the Cube, Stavros and his team have curated an ecosystem that is home to most of Athens' technology events, hackathons, innovation sessions, and training events. Prior to founding the Cube, Stavros was a software developer and had a long career working in the government sector in information management roles. Welcome, Stavros, and thank you for being with us today.
Thank you, Lou, and what a fantastic panel. Talk about punching above my weight. I'm really pleased to be here, learning so much from everybody. And I think I'll cover a couple of points around, the Cube, the history of the Cube, but also, where we are today. But hearing everybody's comments, security is probably the overarching theme about everything we're talking about. Security and the understanding of security, of how secure we are, how insecure we are. And potentially for too long, we've been feeling too secure and not innovating enough. And if we look back to how ancient Greece formed democracy, it formed democracy because of an insecure moment. So currently, locally, I think, we have a playground bully in our neighborhood, which makes us feel a little insecure. And that means that we need to innovate and we need to create new solutions. So I'm pleased that we've managed to collaborate with a number of technologists locally to put together SMART, which is a new company founded in October last year. And it seems to be doing very, very well. But I'll go back a little bit about the Cube and about our journey within the innovation ecosystem and hearing what Vincent opened with and comparing to how we currently are to how we were. I think we still are lagging very, very far behind from other advanced innovation ecosystems. In fact, we started incubating during the innovation ice age, I would call it, here in Athens, where collaboration and interoperability between organizations, between government, between academia, between the private sector just wasn't there. And Tom alluded to that earlier on as well. And I'm pleased that he's recognized that things are slowly changing and we're having better outcomes. So, back then, it was difficult to actually get people to collaborate because nobody really wanted to be led. And Greeks are really difficult to lead. We do very well on our own. And Tom, being an expert in his field, has done very, very well outside of Greece. But if he was in Greece, he probably would have had a significant challenge trying to do things locally because the ecosystem here is actually very challenging. And I'm pleased to see that we have Greek experts everywhere. That's a wonderful thing. But about leadership, there's an expert called Brad Feld from Boulder, Colorado, who talks about how startup ecosystems work, about how every entity should compose the startup ecosystem, whether it's academia, government, finance, but the entrepreneurs as well. Everybody's trying to lead that ecosystem, but his position is that the entrepreneurs should be the ones that lead it, not only because they're in it for the profit, but they're in it for the long run, the long term. They have 20, 30, 40-year plans. Governments probably have 3, 4, 5-year plans until the next election cycle. And being in as an entrepreneur, I often wish I should be in a position to be able to lead it. That said, we probably don't need leadership in the sense that we would expect a leader, a general of an army or a general of a military force, but perhaps we need leadership in terms of a big picture, big objectives that a society or a country can subscribe to. And I think perhaps as Greeks, we've kind of have a little bit of an identity crisis in terms of where we want to be and how we want to be and what our role is in the world. And while we want to be an independent country, I think we're more an interdependent country than an independent country. But I would have liked to have seen faster innovation. I'd like to see better defense capability, defense innovation within our local ecosystem. And that's why we put together the team to create SMART. So very, very briefly, what SMART is effectively a drone company. We thought, how difficult can it be for us to put together the parts to fly a machine at a great height and put a sensor in the air so we can basically have a flying camera And from there on, you know, the world's our oyster from what we can do with the data that we see, applying machine learning and machine vision to the data stream that comes down. Once we've managed to secure the link, because again, I'll come back to security, and I'll talk about security quite often during my brief remarks here. We can do some amazing things. So our objective is to put a sensor in the air, make it fly for a long enough time, do it cheaply so that when we lose that sensor, because right now, if you might know what the average lifespan of a UAV in the Ukraine conflict is. Does anyone want to guess? Just throw a number out there. A few days, a few weeks, a few hours. What do you think?
3 days?
3 days? That's a good guess. Anyone else?
I thought I read a stat recently that was minutes because they're plopping them up left and right.
So the average lifespan of a UAV, not a drone, a UAV, is 11 hours. So they are basically dropping out of the sky. So we need to make them cheaply, and we need to make them quickly. And when I heard Eugene's idea about the containerized factory or the factory ship, this is an idea that fits very, very well with doing your production or your repair very, very close to where the tactical area is. But not only because it's close to it, but also because it can be easily distributed. So you don't have one target to protect, but you can distribute your production, and it's much more difficult to disrupt. So going back to smart, we created something within 3 months, putting all the parts together and flying a prototype very, very quickly, much faster than any other local entity was trying to do with much less money. We are privately funded. The 3 founders are basically putting their own time, their own money. We are currently fundraising for our next phase, but right now we have a working prototype that goes up in the air, flies for 4 hours at a 40-kilometer range, and can identify a target and classify a target, but also predict what that target will do. Because we can take the data from what the ground is looking like, what the weather is looking like, what the condition of the ground is, and give an operator on the ground, whether it's a commander or if it's a civil defense actor, an indication of what might happen. What might happen. It's important to understand what's going to happen in 30 minutes, not what happened 3 minutes ago when you received the picture. You're not interested to understand that someone walked through, or a team of a tactical team moved through a specific area, but you want to understand what the strength of that team is, of that force is, and what that force will be doing in the next 30 minutes. So you can give the commander time. That is the most valuable asset any commander in the field can have. It's time to strategize and time to protect their assets, toward their objective. So fast iterations is a very, very important part of how we need to be innovating today. The off-the-shelf components that we use, still quite difficult to actually source. So supply chain security has been spoken about a few times today, is a real issue for us right now, finding the right chips, finding flight controllers. We're at the point where we're actually considering designing and manufacturing our own flight controllers locally, because they're just in such short supply. So security is a very, very big aspect. And in terms of STEM education, which was spoken about earlier on, super important that we not only STEM education, but I think we actually need to add a C in that STEM, because we need a security, or an S in the end of that. We need security part of it as well, so that anything that we do build has a security aspect to it as well. What are we securing? Are we securing our way of life, our financial security? Someone said earlier on, young couples are considering whether they should bring children into this world. We live in a very insecure world. I don't feel secure at all. So I mean, I don't want to delve too much into much of the details of how we do things, but the important thing is that we do it quickly and we do it cheaply, and we want to be able to give the capability to our defense force, or to any defense force that particularly wants to purchase our product, that they can do it fast, cheaply, and protect their soldiers, giving valuable insights, valuable information to the commanders in the field. So I think, shall we move on to the discussion, because I'm conscious that we've gone well into the time, but happen.
I got to tell you, I think we need another session here.
All right.
It's kind of
Thank
exciting.
you, Lou.
I will say one thing. Stavros, I don't, I'm in the construction world. Okay, so anytime anybody ever brings up the word cheap, I tell them, do me a favor, don't use the word cheap. Use the word cost effective, because cheap signifies something else that cost effective, signifies again something.
Sure.
Else. So Eric, I will open it to you, our technologist here on this particular panel. It's been a fascinating discussion for me. Vince, you can unmute. Everybody, please unmute, because it's an open discussion. We're not going to have a lot of time to chat, but anybody can just open a conversation to anybody else, because you guys are really, really into the swing of this particular panel discussion. Anyone, Eric? Anyone?
Yeah,
Eric.
I want to throw something out really quickly. This gets into what I believe it was Cam was talking about, STEM education, which I've always supported, as you know, Lou. And in fact, Stavros first came into my purview years ago because he was doing a lot of volunteer work with youth robotics, right? Some of us dedicate time on that. But my concern has always been mission oriented engineering. So we have, and my comment on what Tom presented, that's what I do. Supply chain aspects, hardware, software, that's what I do. So my comment was I understood it, but it's gotten so complex now. Is anyone devoting the time for youth and engineering programs? And we tend to separate it, computer engineering, software, and even embedded. Is anyone devoting the time to the youth spend pipeline for all these complexities, right? These mission specific complexities of your supply chain all the way through, because it is extremely complex once you even drill down one layer. So if anyone can talk to it.
Vince, any comments, Vince, on your end?
So this is where kind of the details of what the engineers are doing on a curricular basis get a little bit away from me. But I will say this: one of the ways that we're trying to particularize the things that our students are learning is really devoting a ton of effort to placing students in well-defined internships where they're not just making coffee, where they're actually in a specific field of endeavor. And that means those of you that are out in the field, that means actually educating an internship placement and saying, you take a student in as an intern, it's not free labor. You're going to be spending time educating this student and training the student, giving them an insight into what's going on in your field. So much. I mean, I'd be very interested to think about how, as we increasingly start to focus the output of our engineering school on specific areas of endeavor and specific problems, bringing that in is really interesting. I don't know that we're doing that right now, except via interactions with industry.
I won't say that I have a perfect answer for that, but what I will share is the principles that I've tried to approach to balance both, the need for giving specific guidance and then self-discovery and everything else. My father used to say, we don't have family rules, we have principles, because only people without principles need rules. And so the way that I like to baseline the principles of constructing an internship or an apprenticeship or anything else, but especially internships, is help define the outcome and focus on the outcome, not the process. An old mentor of mine who was big into cybernetics was good at saying, hey, and studied industrial work, said you can define for process or outcome, but not both. And so when you define for outcome, what happens is they will run into the complexity and they will have to address it and make trade-offs. And if you have good guidance there, you can choose the moment where you walk up that complexity tree and then give them ways to think about it, simplify it, make choices imperfect, and move forward.
Yeah, I have to agree. I think that, because working at the Naval Research Laboratory, it really upset me to see these interns come in and do exactly that. They do all the menial work, but, my interns, they got tasks. They got real tasks that on the projects that I was working on, and I would give them guidance, tell them this is, say, hey, this is the task. I'd let them go try and figure it out, check on them, and then help them to help themselves. and then go away and come back. I mean, they've got to learn to succeed. And in that process, you take the chance that they're going to fail, but I don't look at it that way. They got to learn how to succeed.
Yeah, absolutely true.
Tom and Stavros, let me ask you guys a question, because Tom, as you indicated, you left the Hellenic Republic, went to a foreign country, and there was a few 100,000 people that left. Many of them went obviously to engineering school. Many of them are very successful in their particular field. And what always surprises me, Stavros and Tom, and Stavros, you came from South Africa. Okay,
both of us left because of security.
Yeah, but
Tom left because of security, and we left because of security.
No, I got it. What surprises me, and I have to congratulate you, obviously, Stavros, with what you're trying to do. What surprises me is that not more of this is taking place when you have a population, in many cases, which is highly educated, with many people going into the engineering fields, with many people obviously in the engineering fields around the world who come from that country. And you're sitting there struggling, doing these little things. I'm just shocked at why the Hellenic Republic is not more advanced in some of these systems. I just welcome a comment on that because it always surprises me. And the other thing that surprises me is in terms of investment, because not enough is taking place. We always have, Hellenic politicians coming to the United States in particular and other nations, asking for money, help, support where you came from, the diaspora, blah, blah, blah. But in reality, there's something missing there. Many of us in the diaspora do not trust some of the people. Can you just give me some guidance in this, because it's kind of surprising to me.
I mean, sorry, go ahead, Tom.
No, Stavros, you go first. You're closer. You're in Greece.
So
I'll give you the outside-in perspective.
A brief remark. I don't think I'm going to waste any time trying to convince the local government to fund us. My time is better spent innovating, finding team members, convincing private investors to support us, and getting it done. We have a partnership with a Ukrainian drone manufacturer, which we supply data to and part of our machine learning model to, and they had been building drones for 25 years. The Ukrainian government had bought 2 before the war started, and for many years they had been trying to sell them more, but the Ukrainian government was not receptive to buying more drones. They felt quite secure. The day after the conflict started, they were called in and asked for 200 drones. In our case, what I'd like us to achieve as a team is to have the capacity and the capability and the understanding of how to build these quickly and how to iterate on them quickly, so that when the need arises, we'll be there and ready to supply. Our customers is not the Greek military. The Greek military is secure enough, and the country is secure enough at this stage. And there are other insecure places in the world that we can sell to. It's a very big market. Greece is not our market. Greece is a very, very small market, and we're doing, I think, what Tom mentioned earlier on. We're testing locally, hoping to sell globally. Go ahead, Tom.
Yeah, so historically, governments do not deliver results. It's the private sector that delivers results.
That's why I was surprised at your comment about collaboration and all the rest of that with the government. But that's okay.
Well, I mean, in the government, the only thing you can push is certain to provide incentives or regulations, all right? But at the end, if the government came and said, gee, the global supply chain problem, the DoD and big tech together, they cannot solve it. And that requires an orchestration of ecosystems along the supply chain. And we're going to incentivize that. So if you're part of it, you get the incentive or not, that's good enough. Because once people try it, they will find other business incentives to make it happen. Now, the other thing is that government may think that they actually provide incentives for growth, but they're not. Example, in 2009, when I got involved with the Greek innovation ecosystem, they were having the microelectronics funds that were like 10 or 20 or 30 million euros. And you had all these little startups basically saying, hey, I want to tap this money. Here's my innovation. And you would look at the proposals, there would be about 70 or 80 or 100 pages to something that in America we would do in 10 pages because they have to show the bulk, they have to show there's a lot of work behind it. And then you would ask, so, okay, you had a good idea here. What are you going to do with it when you get the money? Well, I'll get it from the lab, get it to work and then put it on the shelf and go for other money. So in other words, there was this constant engineering talent delivering prototypes that would never were commercialized. Then when a VC saw that, he went to Jeremy and said, why don't we just put a fund between the US and Europe where we take the next level, these prototypes, to basically get them to productize. And the first thing that they ran into was, no, you cannot do that. I says, why? Because the EU does not allow members of the EU competing against one another in the marketplace. Think about that, all right? So you fund all this innovation, but you cannot take it to the market because you cannot compete with another EU country, all right? So there's a lot of things that evolved since then, all right? I mean, clearly, there have been funds that came in, there were collaborative funds, and the mindset started improving as a result of certain exits and certain successes. This company got bought by 10 million, 100 million or whatever. So the youngsters, the entrepreneurs say, wait a minute, why am I spending all this time just to innovate? I can innovate and monetize. And you can see now a lot of activity around, around educating people, how to build a startup, how do you get funding, how to be how do you create your idea and take it globally and so on and so forth. And you see a lot of movement, and that's why we had essentially Mr. Dimas and some other people from the top cabinet coming here in Silicon Valley. We created the Silicon Valley Greek Club. They came in and they say how we can basically build bridges. So there's a lot of good activity, all right? And the latest government does a lot of good things in that direction, simply because the prime minister is a graduate of Harvard, and he knows how to put the things together, even though moving the legacy country in the mindset, which was always, oh, my friend did a little coffee shop in this corner, I will open up mine in the other corner. All that mindset, cultural mindset has to change, but we're putting the seeds for that to change now.
Thank you so much. I think we've talked a lot today, and unfortunately, we're running out of time. But I would like to get us all together. But before we close, can everyone give us their thought process on this session and maybe where we go from here? Because I think we need another one of these panel discussions in the near future to further discuss what we discussed today. So, Vince, would you like to start off some final comments?
Oh, listen, I think the things that I said about positioning the university feeds into a lot of, what people were emphasizing, but also some of the needs that exist out in industry. And so I think, for me, helping to clarify that linkage and do what we can to build it would make perfect sense.
Thank you so much. Eugene?
Yeah, I think it was set up perfect. I mean, the way everything was laid out and it just rolled all the way through. I think Eric, you did a fantastic job with the technologies and putting them together this way. The only other things that I had to say is Stavros, have you ever heard about Oxetics? And
Never heard of it, no.
Okay, so we need to talk,
All right.
and then I want to ask Tom, when are we going to start our collaboration media platform?
Cameron.
I just want to say that my thought always is there's a lot of good intent and will and people sitting in their islands who want to collaborate. There's always room for a catalyst. And so for anybody who listens to this, if you think that there is value in this potential, if you see a way that you can bring and take value from being a catalyst across these systems, I encourage you to reach out. Now, that's some mythical VC or investor who might want to come in and fire it up or have a problem or an opportunity to help get us all going. At the same time, to anyone who listens, but especially to my fellow panelists, I am open to freely discuss our approaches and what we're thinking and opportunities for collaboration. Our primary way of trying to collaborate, because we're so focused on just, as many of us, bootstrapping what we do, is sharing our insights or our thoughts. But if there's a way to go after mutual opportunities through sharing of data, diversity of environments to validate concepts, very open to that. You know, I want to put money where mouth is. That's it. Thank you.
Stavros, some final thoughts, comments?
Final thought, both opportunities and threats are wonderful, wonderful things. They help us innovate. I'm encouraged that our alliance as countries, the US and Greece and the US is growing stronger and stronger. We're doing great things together. I've been very happy to be invited to this. Thank you, Lou. Thank you, Eric, and all the rest of our esteemed panelists.
Eric, your thoughts, and thank you again from all of us, actually, for putting this together, you know, because it was an exciting panel discussion, I thought. And some of the things that came out of this, I'm sure, will create other linkages between the people on this panel. Eric, your thoughts?
I just would like to thank the eclectic group with all these shared common threads for attending this conversation, because it is very hard to track a conversation. Like I picked out you all because of those very specific areas. When Lou brought in Vincent, I said that's perfect too. So I'm really happy you all attend, and thank you all, and I look forward to doing this again.
To the audience, thank you for being with us today. Join us on August 6th, where we go into a different path at this time, not technology, but basically more history, and where we discuss the legacy of Cleopatra. Cleopatra, and it's on her anniversary, by the way, the anniversary of her passing on August the 9th of 30 BCE. Many people think of Cleopatra as the seductress, etc., but Cleopatra was a genius of her time. She spoke 7 languages fluently, besides her native Hellenic language, the Guinea that she spoke. But also she was one of the only Ptolemaic rulers that actually spoke the native Egyptian language, knew how to read hieroglyphics and all the rest of that. She was trained and educated by the most intelligent people of that period. She was trained in astronomy. She was trained in mathematics. She was trained in all types of things. And she was also a genius, a geopolitical genius of the Eastern Mediterranean. So I hope you join us where we discover a different Cleopatra, not the one that's being always pushed on us, a seductress, etc., but someone who was not only one of the most intelligent persons of her time, but also she was one of the wealthiest persons of her time also. She inherited a kingdom when she was 18. She killed her brother, of course, but that's a separate issue. She inherited a kingdom that was near bankruptcy, actually, because of her father, and raised it up to a certain degree. Do not believe the movies. I hope you join us on August the 6th for a fascinating discussion on a fascinating person in the history of the world. Thank you again, and thank you to the panelists for being with us today. Thank you.
Thanks, everybody.
Thanks, guys. Thanks.
Thank you.